So we are going to talk about two-dimensional arrays. All right. Okay. Let's pretend we have a variable, say picture. All right. So this is how we define an array. Okay. We are going to plug in the numbers inside. But for now, let's pretend we have a simple picture of 6 cells. This is a one array, right? This is 1D array. So it starts from 0 to 5. So you put 6 in there. That constitutes 6. All right. And then how many stacks of such arrays do you have? Okay. This is the second row, a third row. So how many rows do you have? So you plug in that. So in a way you have to say this as 3 arrays of 6 columns each. That is how you have to say. This is, you cannot say this is 3 rows and 6 columns. This you have to interpret this as 3 rows, 3 arrays with 6 cells in each. Okay. So this is a one array. This is another array. And this is another array. So so that is one simple interpretation of a two-dimensional array. Okay, one second. Let me save that. So, okay. Right. Let's go back to our stuff. Here, I'm going to erase certain things. And the way they're arranged in the system, right? In your hard disk in memory, the way they are arranged is a sequential. They are not arranged like two-dimensional matrix. They are arranged in a one-dimensional okay. How is that? In this case, for instance, let's take a blue color. The very first array, which is this one, right? Is arranged like this. The second row here is again arranged next to it. All right. And the third row is next to it. 0, 1, 2. So in the system, they are arranged from increasingly address space. If this cell address, let's say, I'll change the color here. If the address here, let's say it's 4460, this is 4461, 4462, 4463, 4464, 4465. So this is 4465, right? Which is this? 4465 is the address. The next element is stored very next to it. So it is 4466. So this is the address of this is 4466. So 4467, 4468, 4467, 9, 4470, 4471. So this is 4471 is the address for this. Okay, the address of that is 4471. So for this address is 4472. Okay, so 4472. Then 73, 74, 75, 76, 77, 4477. So in memory, it's arranged as a one-dimensional data. Okay, you may visualize as a 2D. Okay, in other words, even though you defined as a 2D array, our system stores in one-dimensional. So no matter if you have 2D, a 3D, 4D, you pick up any dimension, the system will always store in a one-dimensional. Right? So I'll give you some problems right now. Give me a second. All right? Okay. Let's go back to our here. Now I have, what is this index? Index of this is what? Is 1, 2, right? Everything starts from 2. So 1, 2. When I say picture 1 and 2, which indicates this cell, how does it point in this maps to this one-dimensional internal array? It's very simple. 1 times 6, how much is that? It is 6 plus 2. How much is that? 8. So 8 is the beginning, is the address of the cell, which is 1, 2, 3, 4, 5, 6, 7, 8. 8th is the index, right? Say 0, 1, 2, 3, 4, 5, 6, 7, 8, which is what it is. So it maps your 2D coordinate into a one-dimensional very easily by multiplying the row times number of columns plus 8 plus 2 will get the, so that is how it's is done. See, in another words, you can declare a two-dimensional array but still access as a one-dimensional array. Right? We'll solve these problems as we go, but as long as you know, one second. Okay. As long as you know how to map a 2D array into a 1D array, you are good to go. And similarly, when you access as a one-dimensional, you can always go back as a 2D too. Okay. Okay. So that's about the internal storage of 2D arrays. So how do we access? Very simple, right? Picture, let's say second row, third item column equal to say 89. So you stores in the two-dimensional at row, at column 3 it stores 89, and this is for to write. To read is also same thing. If you want to store in a variable x, you just say picture, or let's say fourth item. So you probably done this in Java class, but we'll anyway go over this. So you know how to read and how to access, right, on a 2D. How do I use a for loop to, let's say you want to print, we have a integer picture, let's say same as before, 4, 6 is the array. How do I initialize all values to 0 using a for loop? For I equal to 0, I less than 4, I plus plus, 4, j equal to 0, j less than 6, j plus plus. You can say picture, I, j equal 0. So this will initialize the array to 0. Okay. And there's also alternate ways of doing it. We can also do in one shot. When you declare here, let's say I can say like that. That's also will do it. But I want you to learn the hard way, like this. Why? So if you want to put any values in a two-dimensional array, this is the way you use it. And if you want to print anything, you can also use the same for loop. to print the values, printf, right? Okay, all right. So this is where you access read and write. You use for loops to initialize or access the data. All right. So that is why you access a two-dimensional data. Very simple. There is no rocket science in here. But all you got to remember is in systems programming or in your system, a 2D of data is always stored as 1D data, as a long string. Okay? If this is row 1, 2, 3, rows is stored here, second row is stored here, like it goes on. Okay? In essence, this first element in the second row is stored very next to the last element in the first row, if you know what I'm saying. Okay, so that is how any n dimension. Okay, one second. Okay, so if to declare a n, let's say a 3D array is very simple. Picture 10, 4, 4, let's say 4. You can conceptually, you can visualize this as 4, okay, 4 by 4, and 10. You can visualize like that. So this is 4 by 4 and 0, 1, 2, 3 up to 9. You see that? But internally, the system still stores as a big 1D data. Okay? System internally stores as 1D. Okay? I will just store it here just in case. Okay, so let's go ahead and write a program and show you how it's done. .c, okay, and I'll just write a simple program for you guys. Picture 4, 6. right? Like we talked how to initialize a 2D for I equals 0, I less than 4, I plus plus. Alright, usually better to do it like that. So picture very simple, and if you want to print it, but if you want to print it in a row by row, right, you pay attention to this. Alright, row by row, you see that I have to do two printfs, one for the end of line alone. So what it does is, okay, this for loop executes, oh, it should be 6. This for loop executes this printf 6 times. When it's done, it puts an end of line and goes back to the next for loop. That's what it is. So let's compile it. Okay, we have error 18. Oh, I didn't put the, okay. Yep, 6, and we have 4 rows. Okay, we can also initialize a easier way. Instead of using a for loop, if you want to initialize in one shot, that's it. This is another way to initialize all of them to zeros. Alright, that's one way of doing it, one method, but you can also go ahead and change it individually, each and every row. You can do either this, go ahead and do for all the elements. Alright, go ahead and fill it up for we need 16 elements, right? So, oh, 24. Okay, I'll just make it it should be, let's say, picture 2. I'll make it like a 3 columns each. That means 12. I don't need that. Alright, okay. Okay, basically I made it as a 12, the second one. So that is another way to initialize the array. You can there are various ways to initialize this is a second method. third method is picture 3. I'll just make it that. You can do each and every row, 1, 2, 3. Then one set of rows, and see braces for, you have to close and open and close braces for each row. And this is another way of doing it. Okay, so this is enough for this course, how to initialize two-dimensional arrays. You can compile it. Yeah, I can go ahead and maybe print picture 3. So you have to make sure that you change all these things. I've changed this condition for the for loop based on the array sizes. Okay, so we can compile it. Yep. So there are various ways to do it. I will just add this program to your PowerPoint. All right. Okay. We looked at 1D and 2D arrays. We saw 3 methods to initialize. 3 ways to initialize, and 1D is also same thing, to initialize the different ways. And we saw how to print using for loop, read and write for using for loop, right?